Hey, third grade, how are you doing? We're going to go ahead and have our video for this week. The things that you'll need are the Star Master Quick Review book, so make sure you have that. You're going to need a pencil. You're also going to need this packet, the fraction packet for Math Lab. So grab those two items, come on back, and let's get started. One of the things I want to remind you about is that we always use our cube strategy, okay? We need to circle numbers and units, underline things in the question that we need. We box our action words. Those are the words that tell us whether we're going to add, subtract, multiply, or divide. Evaluate what you need, eliminate what you don't need. Okay, and show your work and check. All right, now that we've reviewed that, we're going to be on page 62 first in our book. So I'm going to circle that up. It's over here. See me circling that? And so page 62 is where we're going to work first. Now this is going to be a little different from last week. Last week, we went through the questions basically together. This week, I would like for you to do number 1, see right here, and number 2 on page 62. Okay, I would like for you to do those right now. Pause the video and then come back and we'll see how well you've done on page 62. All right, so pause, stop, and when you come back, we'll talk about how this problem is solved. Okay, did you solve number 1 and number 2 on page 62? Let's take a look at number 1 first, okay? On there, we're given Mrs. Howe owned 648 acres of land. She sold 285 acres to her neighbor. How many acres of land did she own after the sale? Now, I boxed that because I need to put in my head, this is what happened after she sold. But what does sold tell us? Does something being sold from Mrs. Howe mean she gets more land or less land? Well, let's think about that. What would that mean? I'm picking up a pen right here. Would I add more acres or would I subtract the acres? Well, if you've sold something, you have less, don't you? So this was a subtraction problem. It wasn't a too terribly hard subtraction problem, but you had to make sure that you didn't fall into the trap of subtracting wrong. So let's go through how we would subtract. 8 minus 5 equals 3, and I know I can do that because the big number's on top. 4 minus 8. I have to think about that. 4 is littler than 8. If I have 4 things, I can't take 8 away from that. So what I'm going to do is I need to regroup some things in my problem. So I'm going to take from the hundreds place. Okay, that's going to change that to a 5 in the hundreds place. And then I'm going to give to the tens place. So now instead of a 4, I have a 14. So 14 minus 8, what would that be? Okay, 6, and 5 minus 2 is 3. And then we would place those over here into our, this is called a grid answer. And then you'd fill in the bubbles that you need with that. So we had to think through that problem. Now my next problem is number 2. And this one says, Mrs. King wrote these number facts on the board and asked students to list 2 more number facts in the same fact or in the same family. Now, if you're talking about a fact family, first of all, we need to notice the operations. We have a multiplying and a dividing. Good. Those belong in the same family. Multiplying and dividing are a family, and then adding and subtracting are a family. We don't mix those families when we're talking about facts in the same family. So if I look here, I have a 5 and a 6 and a 30 in this fact family. So I can also think of my fact family in a triangle here. And in this triangle, I would have my 30, I would have my 5, and I would have my 6. So they each take their own corner or their own little angle in here. And look at what we can do when we look at this. We can say 5 times 6 is 30. Okay? So then when we switch to the opposite operation, dividing, we want to put that big number first. It's the thing that will be divided up. It's the one that will fit into our fact family. Okay, so 30, so we come back over here, 30 divided by 5 equals 6. That means when we're looking for our answers over here, first of all, we have to take off anything that is not a multiply or divide problem. They don't fit in the same fact family that way. So I have to take off C and I have to take off D. No way they could be in this fact family. Another thing I need to look for is that we're using the exact same numbers in each problem. A 5, a 6, and a 30. Come over to this one, a 5, a 6, and a 30. I would look for that over here. Well, I find one that doesn't go with that. So I don't think that this one's going to be the one that worked, but just to make sure, we want to come back over and we want to make sure that we can make what's given to us in letter B, or our answer B. So underneath here, well, looky there. I'm going to come over here to my triangle again, and it's 6 times 5 is 30. And that's true. You can take a multiplication problem and you can switch the numbers there, and that's called commutative property. You can switch the factors in multiplication, and that's what's happened here, and you get 30. And I can divide 30 by 6 and get 5. You use the same 3 numbers for your fact family, and look, we came up with the exact same thing. Okay, so our answer for this is B, and we've proved it by showing it right here. Now I'm going to go to our next page. Our next page is page 63. On page 63, these are a little more challenging. The problems are going to get just a little bit harder, but we're going to work through these two together. On this one, it says, a store clerk used 2 whole rolls of wrapping paper to wrap 6 gifts for a customer. Each gift required 2 feet of wrapping paper. How many feet of wrapping paper did the clerk use in all? Well, let's come back here and let's understand what we're looking at. Okay, so we see that there are 2 rolls of wrapping paper. There were 6 gifts that were wrapped, and each, that's a word that we'd like to box because that word tells us something. It's either multiplying or dividing. That's what the each is going to give us a clue for. And each gift requires 2 feet of wrapping paper. Now, our question, how many feet of wrapping paper did the clerk use in all? Okay, so we want what was used in all of the wrapping paper. Now, a lot of times if each is in the question, like this part right here that had the question mark in it, that would mean we're dividing. A lot of times if it's up in the information part of the problem, we might be multiplying for our answer. And then we also had in all, which is an adding clue for an answer. So we have an adding clue, we have some multiplying clue because this was given in the information. So what I'd like for you to do is I'd like for you to pause the video. I want you to try to draw a picture of what's happening in this problem. After you've drawn your picture, come back, we'll talk about it. So Pause and draw a picture for this problem. All right, did you draw a picture? I want you to look at the one that I thought to draw. Okay, so my customer has 6 gifts that need to be wrapped. Each gift had 2 feet of wrapping paper used to wrap it, and then there were 2 rolls of wrapping paper. Okay, now my question says, how many feet of wrapping paper did the clerk use in all? Well, if I look at my problem here, this had 2 feet, and 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 2 feet right there. Well, that's all the wrapping paper that was used to wrap these presents. Now, this problem had another number in it, though. It said there was something about 2 rolls. Did we need the information about the 2 rolls? We don't. All of our information is over here in this part of the picture. This is part of what we talk about when we talk about, let me put our cube strategy up, when it says we need to eliminate something. Eliminate means you have to get rid of information sometimes. We didn't need to know that they used 2 rolls of wrapping paper. All we needed to know was how much wrapping paper went on each present. And you could have used adding for that. 2 plus 2 plus 2 plus 2 plus 2 plus 2. Or you could have said 2, or I wrote a 6 on there. 6 presents each use 2 feet. Either way, you would have come up with the answer 12. All right? Now, let's look at number 4. At the end of, and remember, we are still on page 63. My page is just gigantic on here. Number 4. At the end of the first half of a football game, the Cowboys had scored 28 points and the Broncos had scored 17 points. The Cowboys scored 14 more points in the second half of the game, but the Broncos scored no more points. Which number sentence shows how to find the difference between the Cowboys and the Broncos' final score? Well, let's go back and look at our information. We're talking about at the beginning of this, okay, we talked about the end of the first half. And you know, we take a break in half times on a football game. And it says that the Cowboys, so we're talking about the Cowboys, scored 28 points. And the Broncos, so this is the Broncos score, 17 points. Later after they came back, okay, the Cowboys scored 14 more. We've talked about that word in class before, 14 more points in the second half of the game. But the Broncos scored no more points, so that's a 0, okay? No more points. Which number sentence shows how to find the difference? That's one of our words that we would do in class where we would go up and down for the different meanings of the words. So, which number sentence shows how to find the difference between the Cowboys and the Broncos' final scores? So we want to find the final scores. Pause the video. Try to organize your information with what you know, what you need, and what are you going to use to solve this problem. Then come right back and let's compare how we did. So pause now and do some work. All right, I'm going to show you how I set this problem up. I had a Cowboys side and a Broncos side. On the Cowboys side, I put the 28 and I put plus 14 because that's what Moore told me to do. I needed to add 14. Now I went to the Broncos. I gave them their 17 points, but then I had to add nothing because there were no more. So I added no more points to that, and that means they ended the game with 17. Now, My final question is, what does difference mean? If I want to find the difference between the Cowboys up here and the Broncos down here, it means I need to find that space between. Difference means to subtract. Remember when we heard difference in class and we would go down? That's what it means here. So we would subtract. Now, if I look at everything that I have right here, and I check out what I have right here, I did this in my problem, but that's not all I needed to do. So that can't be my answer. It didn't have everything I needed. Now, nowhere in my problem do I subtract a 28 and a 17. I added a 28 and a 14, okay, but I didn't ever subtract. That won't help me get my answer. Now, I did a 28 plus a 14, but did I need to add 17 in the end to find a difference? No. So this 17 right here did not need to be added in. That's not my answer. D has my answer. I did a 28 plus 14, and then after that, I would subtract 17, and that would have helped me find my final answer. All right, so we're going to go on to that fraction page. And this isn't going to be a very long explanation, and I know that I gave you 4 fraction pages that all start with the FC. So I gave you FC 1, 2, 3, and 4. I'm only going to talk a little bit about FC 1. You know, before when we had talked about fractions, we had a whole thing that was chopped up like a circle, chopped up into like pizza slices. Well, this is a little bit different. Fractions can also be sets of things. So if you see different items being talked about, this is called a set. And within a set, you can find a fraction, or what fraction of the set is a certain item. So if we look, let's remind ourselves about what all fractions have. They have a fraction bar, and they have a number on the top, and I'm just going to put a little number sign right there, and a number on the bottom. And do you remember the number on the top? It's like we nodded, okay? That's our numerator, and the number on the bottom is the denominator, and we dance our denominator. Remember that? So we'll need a numerator. Those are the things you're looking at. The denominator is the whole set. And then the fraction bar separates the two. So let's see how this set looks. If I look at this set, I notice that it has diamonds, it has a circle, and it has a cross. So my question asks, what fraction of the group is diamonds? So if I look at my group, the first thing I need to do is draw my fraction bar, find out what is the total amount of items in my set. 1, 2, 3, 4, 5. 5 items. Okay, then I want to figure out how many of the set are diamonds. 1, 2, and 3. 3 of them are diamonds. So what fraction of the group is diamonds? 3/5. Remember, you put the TH on the denominator number's name. All right, so pretty easy to do, but let's do one more, okay? And so if I look at this, here is my entire set. My set has 1, 2, 3, 4, 5, 6, 7 items. The denominator is the whole amount in the set, the whole thing. Now I need to figure out the fraction that are stars. So let's come back to our set and only check out the stars. I have a star here, 1, 2, 3. 3 out of 7 things are stars, or 3/7 are stars. Now, if you'd like, I gave you plenty of papers to practice on. Go ahead, choose a paper that you like. You don't have to do all of them, but if you want to, that's great. All right, so we're coming to the end of this week's video. This is the week of April 20th through the 24th. I hope that you have a great rest of your week. I hope you've learned a little bit of math today. Love to see you guys on Study Island. I am so proud of those people who are sticking with it. And until next time, bye-bye.